I'll do this. All right, folks. Well, good afternoon. Thanks for popping in. I really appreciate it. Happy Tuesday. It is, I guess, the midpoint of our week because we're done today. We got 2 days left, and then a whole bunch of sleep-in days after that. So that's going to be great. Today, I want to go over what we were talking about yesterday. So we talked about some of the theory concepts behind welders, and I'm going to show you one of the ones that we use in the shop here. This is our Miller XMT 350. It's a constant current, constant voltage setup. It can do numerous things. Very, very useful machines and a great foundation to start building off of. Instead of buying a specialty TIG machine, specialty MIG machine, specialty flux core machine, we can take this power source, put it in a cart like this, add some extras onto it, and make it a very useful piece of equipment that can do a lot of different things. So this one is set up right now for gas metal arc welding, S6 hardwire. And I've got that gun right here, you can see, right off the side of the bottle there. And this side of this unit controls this. That is, if we select that side. This here, we have to select which side of the unit we're working with. And what we have here is our T11 or T72 flux core, 71, not 72, flux core. And this is an 045. We got our gun set up here for that. Our remote's plugged in. And you guys are slightly familiar with this part because we did have you guys in the booth a little bit before we kicked you out of here for the break. So I'm going to back this up a bit so you guys can see it a little bit better. It's a little bit close, but that's a little better. So these machines here, fairly small all in all. So looking at it from the side, it is 22 inches long, 15 inches wide, and probably 20 inches, 18 inches tall. Fairly small, does weigh probably about 75 pounds. Maybe a little less. Fairly portable, needs a good power input, but I don't like to move them. Once they're set up, I like to keep them where they are. That's just because these are inverter technology. There is some expensive components in there that I don't want to have to replace. Well, no, I can't replace if we get it damaged. So it stays in this machine, in this cart, and it's just a nice setup for everything here. But we're going to talk about some of the features of it, what it can do, and what I like it for. So we're talking shielded metal arc welding. And shielded metal arc welding is a pretty simple process. Once we break it down, it isn't anything too complicated. These machines are probably the most complicated part of shielded metal arc welding, besides putting in the time to get good at handling the rod and rod manipulation. But setting these up is the biggest hurdle because a lot of people look at these and they see the off on button and they're like, cool. They flick it on and then all of a sudden you do that, you got a bunch of numbers are going to show up on here. And a lot of people are like, ooh, what do those mean? What are those? And right now I'm looking at 71 volts and 114 amps. So this side of the screen here is going to be volts. This side is amps. This right here, 71, that's our open circuit voltage. That's what we have at our disposal ready to go. I never really worry about that though. That number isn't important. The number on the right side is, so that's our amperage. That's how many amps we're putting down through our welding rod. If we're working with a little small rod, say like this one, 3/32 of an inch, and you run 114 amps through it, you're going to get halfway down the rod and the whole thing's going to glow red and it's going to droop and fall apart on you. It's just going to be overheated, and basically we're passing so much electricity through this whole thing that we build massive amounts of resistance. So yesterday we talked about steel not being a good conductor of electricity. Gold, silver being the best, copper, things like that. Steel, it does conduct electricity, but it's definitely not the best. So electrical resistance is heat. That's what it turns into. It's trying to force all the stuff in there, all these electrons coming down through the end. They're all bumping and jostling. That just creates heat because there's resistance there. There's no free flow for them. And it warms us up. Eventually, this whole thing warms up to the point where it's glowing red, falls over, and just burns anything in sight pretty much. And that's not the effective way to run this rod. So we need to run it in an amperage range that is going to allow us to burn this whole thing off without getting overheated and stuff like that. So for rods 332 size, I started about 75 amps. So if I've got 114, I've got 39 amps too many. So that is, yeah, a little on the hot side. Yeah, something like 39, I think. Just double check my math here. Long story short, we can adjust this volt amperage right here with this dial. So this is kind of in the way. See if I can tuck this out of the way. You see that a little better. No, this one's in the way. So this dial right here allows us to adjust our amperage up or down. I don't even know what this machine goes to. So crank up all the way, maximum 425 amps. This machine is topped out at 425. I've never had to run stuff that hot. That's pretty darn big. I've run 300 amps, but I've never run 425. I could. It's not the greatest for the machine because you're really just stressing it super hard. And it's not necessary for what we're doing in here, so I just don't even go into that zone. And we can drop it right down to 0. So 0 to 425 amps, pretty big range. But that's just a nice little dial control right here, and that's stick welding. But if this isn't set up for stick welding, it's set up for something else, we have to adjust all this. So when this was set up for wire feeder, we had the power lead for the wire feeder, which is right here, connected to the positive terminal of our welding machine. We had a ground clamp on the negative terminal down here. That's what ended up completing our electrical circuit for us. We also had a remote cable plugged in right here. And that one's a multi-pin connector. I think it's 13 pin. So we need to be careful with it. So putting that one in, taking that one out, I'm always cautious about it just because it's an expensive little piece. And it's, you know, in shops, things are usually pretty robust and can take some abuse. Those are like electrical pins, those connectors. They're not designed to take abuse. So I'm just very cautious and careful when I hold on to those and I use them. This machine does a lot of different things, but we need to know how to set it. So we have this little panel right here. This one actually flips down. So inside of that, I've got a display here, and I'm going to bring a chair over and set things up so you guys can see it a little better. We're going to bring it down so you guys can see what I'm looking at. See if I can get you right in there, hopefully. All right, you guys won't be able to read this, but you should be able to see it for the most part. So what we have here is, I don't know if you guys can see this orange on the outside, you should be able to. Anything in that setting with the orange on the outside is basically going to mean that we have a electrode or a hot electrode. It's ready to go. So on there, right here, this first one is going to be stick welding. So we're set to that right now. So that means when I have my electrode holder connected to here and I put a rod in, I'm ready to go as long as I've got that ground connection. So that means that rod will strike if it hits steel and could cause unnecessary arc strikes or damage to something. So we just got to be careful when we have a rod in our stinger all the time. This next one here is a voltage sensing wire feeder. So it needs to be active to sense the voltage. So that's why it's on the hot side there. There's a big space in the bottom where it doesn't do anything. Right here is a scratch start TIG. So a TIG gun is a little different. I kind of showed you guys in a video yesterday. But a scratch start is where you physically touch the end of the tungsten to the steel. It makes a connection. It gets ready to start. You lift it off, and it starts the arc, and that's how you weld with TIG. You've got one heat setting. You may be able to vary it a little bit with the thumb control, but we don't have that on our machines. I have a regular TIG machine over in the other booth that I use for TIG, and it's got a foot pedal hooked up to it. So depressing the foot pedal will activate the TIG machine and will allow you to weld. And like I talked about yesterday, it's got a pedal on it, just like a gas pedal on a car or a sewing machine. Down to the floor is flat out 100% of whatever you have it set to, and then you can just ease up from there. You can take a percentage. Right here, I've got lift arc TIG. So that's where you just touch the end and then pick it up, and it'll be kind of similar to scratch start, but different processes. So here, I've got foot pedal TIG. This is on the white side. The white side is not an electrode hot. That's where you have to tell the electrode that you want to work. So that's going to be things like TIG, where you press the foot pedal, you say, hey, I want to work, you press the foot pedal, it starts up. MIG, same situation. You can set that on the table, and it's not going to make any welds, but you pull that trigger, it's going to weld. So these 3 or 4 top settings, you need to activate the machine. Here, the machine's ready to work in the orange section. So that's kind of neat. We got a bunch of different settings here. We got constant current with the pedal. We got pulsed MIG. We got regular MIG. We got pedal TIG. Here we got lift arc TIG, scratch start TIG, stick welding, which is what we're doing. I hate the fact it says stick and it says MIG. I understand why they put it there. That's because it's small. Won't take up a whole bunch of space in that little category for writing, but it's not stick welding. It's shielded metal arc welding. It's just called stick. Same with MIG. It's not MIG. It should be gas metal arc welding. But this is the way they do it. And this is an older machine. Maybe the new ones have changed. I'll have to check that out. I'll have to go look at some new machines sometimes. But that's what they have here. And inside of this cover, which I can't take off, there is some information on what these settings are and what it does. But I basically explained that to you right there, so we don't really need to worry about that too much. This guy right here, this is our arc control. So what we're doing here is we're setting how much force the arc comes out of the end of the rod with. So if we set it at 100, it's going to be harder to stop that weld. To kind of stub out that rod. You can try and jam it on the plate, and you might get it stubbed out, but it's going to resist that as much as it can before it does. If we have it set to 0, any little thing we do may shut off that arc, and that's definitely going to cause us frustration when we're welding. So I set it at 40. 40 is a really good place to learn at. And if we're going to do other things, we can set it a little differently. And this is all going to be up to the user. But basically what I do is I set mine at 40 and I never adjust it unless I'm doing things like open roots on groove plates. Then I'll adjust it there. But we're going to leave that there. We're going to close this panel up. So as you can see, they call these the XMT 350. It's the constant current, constant voltage setup. We can set it up for either. We got our main off-on power switch right here on the bottom. So a big toggle off-on, pretty simple. This side here, what we have is our positive terminal. So electrode positive, when you see something that says DC EP, EP just means electrode positive. So that's where we plug our electrode holder. Electrode holders, our stinger, and I'll show you those in just a moment. This one here has an option for gas out. We can run gas through this if we really wanted, but we don't need to because we have things like this system up here that we can pump gas through. We're not using this one for TIG, so we don't need the optional gas out. I have other machines set up for TIG. This is our electrode negative side, our negative side of things. So if you see something that says DCEN, the EN just stands for electrode negative. So that means you're going to put your holder, your electrode holder, your stinger, in the negative side, and you're going to run the rod that way. It's kind of backwards in comparison to normal, but there are rods out there that run better on the electrode negative side. So that's something we need to be aware of. You can often find this information on the box of welding rods. And I've got a couple boxes up here. I'm going to grab one, and we're going to look at it quick, and we're just going to talk about how to find the information you need on that box and how to set this up for that specific rod. So we'll just grab a random box, and we'll set it up. All right, so what I did is I grabbed a box. I just happened to grab the biggest box I could find. So this is OptiWeld 7018 or OptiWeld 18. A lot of these manufacturers will create their own name for it. And in fact, this one has. I'm gonna move this camera up so I'm in a better position, but we're gonna talk about this in just a second. All right, that's better. I'm not hunched over now. So this is OptiWeld 18. It is a big boy. A lot of big rods in here. So there's some information on here that we want to look at. So right here, I'm not gonna be able to show you. Maybe if I jam it in there real close. Yeah, there it is. OptiWeld 18 7018-1. That's telling you what type of rod it is. The next thing you're going to see is right here, 5 by 450. So 5 means that's its diameter. So our rod diameter is 5 millimeters. Now a 1/8 rod, its diameter is 3.2 millimeters. So that is regular size. These ones are the XL version. So this is 3/16 of an inch by 450, so 18 inches long. So that is
the hell
a
is that
big
so
welding
long?
rod. Bigger than most of us will use on a regular basis. I've used plenty of these. I run these about 250 amps, whereas a 1/8 we run at about 125. So these ones definitely take more juice to burn, but they create a great big wide weld on you. What would I use this for? I would use this for seaming flat plates. So I used to work in a sawmill, and what they do is they bring log ponds, or they have these log ponds, and they dump all these logs in these big ponds, and they would float up onto some chains. The chains would pull them along through the ponds, but those logs would bash off the sides of the pond and kind of beat up all the concrete. Eventually it was starting to wear out. So what they did is they drained these ponds, cleaned them all out, pressure washed all the walls, and ordered a truckload of steel plates, 4 foot by 8 foot by 1/2 inch thick steel plates. What we had to do, take a forklift in there and put these plates on the walls, and then anchor them in with anchors and weld them in place. And then we put another one beside it. But there was that 8 foot long vertical seam straight up, right? So we'd have to weld those. You don't want to weld vertical with something like these. It's going to be really hard. So we weld those with smaller rods. But when we did the floor was 16 feet wide. So that was 2 plates side by side. So we would sit on stools, or like auto mechanics creepers, you know, those little creepers you sit on to roll under a vehicle. We were sitting on those, and quite literally, I'm gonna turn this over here. You'd have your joint in the floor here. You put your creeper right over top of it. You sit down, a bunch of welding rods on one side, and you literally just welded and use your feet to push you backwards as you welded on that joint for 16 feet. And then you turn around, go back the other way. Was it boring? Heck yes. Did it pay well? Heck yes. So, big joints, big thick steel, 250 amps, a lot of heat, but it does a good job of what it does. So our job was to close all those seams so log debris, water couldn't get underneath them, and it keeps those down to the floor. So that's what we were using those for. If you're working on big flat steel, horizontal even, you could weld with this. I only like to use this stuff in the flat because it's just so big that you have such a large weld puddle, it's hard to control. But all the specs you need for this are going to be on the side of the box. So I know a 718 is going to be welded. Yeah, go for it, go for it. 17 is going to be welded with electrode positive. So we are going to start by setting up our machine electrode positive. So we're going to go here. And I'm going to grab Stinger, which is this guy right here. So this is our Stinger. We saw this in the video yesterday. In fact, almost an identical picture to this one. It's got our cable on it. I don't know, 10 feet of cable, maybe less. And then our twist lock lug connector on it. So this has got a little nub on the top of it. It's hard to see. Maybe you can see it right there. Yeah, you can see it there. That goes into the machine. It twists in behind a stopper and prevents it from coming out. This is our positive contact. So if we are welding electrode positive, we're going to put this on the positive side of the machine. And that's identified by the plus sign. Nice and simple. So that's twisted in, it's locked in, it's not going anywhere. Awesome. So we got the electrode holder. Now we need the ground. Yeah, go do what you gotta do, Mickey. I'll post this video later. You can catch up on anything you missed then. So now we got the ground clamp. So our ground clamp here, cable, this cable here comes up to the back of the clamp. It's connected by a lug connector right here. We got to make sure that's tight all the time. If we get a bunch of resistance in here, this whole thing heats up, and this isn't very good when it heats up. It's just you're losing a lot of electricity from the welding process, and you're not welding as efficiently as you could be. Also, twist lug, a little bit different body on it, but same thing. We got that lug on the end. That's going to go on the negative side since it's the only terminal left. All right, we're locked and ready to rock pretty much. So this goes on. Your weld table, which you guys can't see. So I'm going to back this whole setup up, and we're going to go over that. All right, so I got this backed up. See if I can get the table in the picture here. All right, yeah, so we are going to connect our ground clamp right up here on the table. So you guys can see that. That's what we need. Yeah, McDonald's, lucky. I guess I had Subway for lunch, so I can't really say too much. Okay, so we're going to put this where you guys can see it. We're going to connect it right here on the table. As long as it's connected to the steel and electricity can pass from the steel surface into here, that's what we need. You can clip it on the table here, on something on the table. You can tack a little piece on the table, tack it onto there. Doesn't really matter. But there is our ground clamp. Pretty simple. That's a spring operated. This guy here, our weld stinger, electrode holder. It's got different names. You can see that that hole in the end there. That's where a welding rod goes. And let's use a normal 718 for a second. 1/8. We're going to put it in here. So if that's open like it is, we're going to insert the rod in there. We got to insert the bare end. We don't want to insert the flux covered end because that's not going to give us any electrical contact. So this has metal jaws inside that grip on the end of the weld rod. So we put that in there, hold our handle tight. I hold the rod. I hold the rod in these two fingers, and then I grip the head with these two fingers, and all I do is I twist to the right, and that actually closes the jaws. So as you tighten this up, it closes the jaws. This is in there nice and tight now, and you can work with this like this. You can bend it down there, to the left, to the right, whatever works for you is whatever works for you. That is how this works. So to take that out, you've welded down, you got a nice short rod stub. You want to take it out, so what we're going to do is the opposite. I hold it here. If you weld it down to a short rod stub, be aware that this is going to be hot. So make sure you got a glove on. If you're not doing it that way and you just want to get it out of there and you don't want to burn up your glove, you also grab the back of the head like that, give it a twist. That's now loose. That can pop out. When you are welding, I want to see rod stubs burnt down all the way. I don't want to see any rod stubs longer than this. This is only a couple inches here. It's just a waste otherwise. So what I do is when I'm done welding, I keep these little rods. I put them in a rod bucket. In fact, I got a bucket right here at the table from other demos. But those little rod stubs, those are great for tacking your plates together. So if you're putting tacks on the end of a plate, say like this one, I welded this earlier, you can tack those plates no problem. Then you still have a full brand new rod to start your welding with. So that's a good thing. This guy, a little bit bigger. This is that big rod we're talking about. So we're gonna open this sucker up and stuff this big rod in here. 3/16 of an inch, should run about 250 amps. It lists that right on the box. So if you're ever wondering how to run a welding rod, that information is usually right on the box. So we've got this set up now, and that's a big sucker. I don't want to set this on the table because it might, touch this, and this end is always live now. Electricity wants to jump out of here through a metal circuit. So if this touches the table, we're going to get a whole bunch of light and sparks. What we need to do, we need to set up our machine. We need to turn that amperage up, 250 amps, right? So let's do that. So I have that set up now. We got the ground clamp on. We've got the electrode holder in place with the rod in it. We got the machine adjusted the way we want it. I guess the only thing left to do now is to light this sucker up. So I'm gonna grab a piece of steel. I'm gonna grab my helmet, put my safety glasses on, and we're gonna burn this 18-inch 3/16 7018 down to nothing. We're gonna put a giant weld on a plate here. So we'll do that. Okay, this will be awesome. So I'm going to follow a YouTube example. YouTube always says, headphone warnings, turn your headphones down. Well, this is the screen brightness warning. If you have a high def screen, you may want to turn it down a bit because this is going to be bright. What I have is a 1/2 inch chunk of plate here, 3 by 6 by 1/2 inch. I am going to run a few welds on this, and we're going to light this giant rod up, see how it reacts, see how it behaves, and see what the weld looks like at the end. So this is always fun. That's why I love this class. I can do demos, do fun stuff like this, and I get paid for it, which doesn't even seem right because work shouldn't be this fun. All right, so I've got this set up, pretty hot. I got this giant rod here. I was gonna try and bend it, but it's gonna be too difficult. So what I'm gonna do is I'm just gonna attack this here. I'm gonna weld a line on the plate, which is called a stringer or a stringer bead. And we'll clean that off. We'll talk about that a little bit. Then we'll lay a couple beside it and see if I can't do a couple passes side by side that look decent. So here we go. Showtime. Whew. That's hot. So stick welding, I have to say, is one of my favorite things. I love the fact that we're on this unit now. But what I got here is thick old plate. Got a big chunk of slag on it. You'll see what I'm chipping off right now is slag. Slag is all this stuff that's on top of the weld. So it's kind of like Christmas, where you get to chip off the slag to reveal the weld underneath. Then we'll take our wire brush right here and we'll brush up the weld so you guys can see it a little better. So there is a big old weld on that plate. It's got big high profile. It's quite wide, probably 5/8 of an inch wide. And yeah, so just for comparison, I'm gonna run another weld right beside it. Then we're gonna run a smaller rod just to show you the size difference and how big this actually is, because in the screen it's never going to translate how big it actually is, but this sucker is big, and I'm actually running it at 265 amps, so it's getting there definitely. We're gonna do one more, then we're gonna put a small rod in and show you guys the difference with that. All right, I'm gonna put this one right beside it, try and build the two up, kind of like our stringer padding we're doing with gas mill arc welding before we went home. So let's do this. So we burnt that one down quite a ways. 3.5 inches left probably. Giant weld on the plate. Plate's smoking hot. It's nice and red. You can probably see that in the camera. We're going to turn this sucker down to 75 amps. And we're going to run some 332 right beside this, and we'll compare the two side by side. All right, so on the flip side, little guys, 332. Holy man, that's hot. I can feel the heat coming off that plate on the back of my neck, and I'm standing 3 feet away from the plate. That's a lot of heat coming out of there. So you got to take that into consideration too. When we're handling these things, definitely pliers, these gloves, they'll burn up in a second. They are leather. Leather is definitely not heat proof, but it definitely helps deflect some of the heat. So I've got this set to 78 amps. That's about where I'm going to run it. I'm going to run it right 2 passes side by side, just like I did with this one, and we're going to compare the 2 passes. So just to give you opposite and extreme ends of the spectrum. This rod does come in smaller sizes. I've used 1/16, which is 1/32 smaller than this. So 33% smaller than this rod. It's very small. You run that about 45 amps. So yeah, here we go. So I'm just going to do a short little one here. We're going to chip it off, put another one right beside it. And we're going to compare the 2 cleaned up finished welds side by side. RIP headphone users. All right, I'm going to cool this down. I'm going to buff it up, and we're going to talk about it. Also, a little pro tip for you. If you're throwing stuff in the quench bucket, those buckets of water I got on the floor here, those are supposed to be for cooling down steel. So that's what we're doing. You're dunking a super hot piece of steel in there, don't lean over it. Steam's going to come up, scald your face, and yeah, definitely not nice. Sometimes it even spits up hot water. That bucket gets real hot real fast, so you don't want that scalding water coming up towards your face. So a little bit of reference for you. So 2 passes of a 3/16, 718, 265 amps, side by side here. This right here, 2 passes the 332 7018 at 78 amps. There's just a little bit of difference in the size here. Not, well, there's a lot of difference in the size actually. But you want to use this on thin material, this 3/16. It's quite big, quite hot, and you got to run it big. So you need some definitely big material to work with. Let's just compare the rod stubs since they're both about the same size. So one is a little bit bigger than the other. Also, if we can see the ends there, you see the core wire in the one clear as day. The other one, hard to see because it's small. What we're burning off. So small, come on, focus camera, 332 right here. Nice, easy to work with. This guy right here, big. This is big time, 3/16. It does get bigger than this. How much bigger? A lot bigger. By a lot, 3/4 of an inch. Yeah, 3/4 of an inch is a big one. Now, those are 4-foot electrodes, 3.5-foot electrodes. They weigh probably 20 plus pounds each. They are designed to be run by an automated machine. There is a video I'm going to include for the heck of it where they run a 12 or 3/4 of an inch electrode, 1200 amps with a giant ground clamp on the end as a conductor for the electrode. And they're holding it in this hand and they're just on a table. It's pretty crazy. So 3/16, although it seems big, it's not big. I've welded with 1/4 inch. 1/4 inch is, it doesn't seem like it's that much bigger than a 3/16, but holy man, we're talking 325 plus amps to run that sucker. It's big, and if you want to run it hot, that's where I got the 365 number from earlier, right? Like I said, I've run 360-ish. That's what I've run that on. It is a wild beast. It is something crazy, and you got to be comfortable with heat. You got to be comfortable with sparks. You got to be comfortable with all that because, yeah, once you fire that sucker up, it's just hellfire and brimstone. That's what that it seems to be. But super cool. I'm glad I had that experience. But that's going to be it for today, guys. I want to go over the parts, the pieces of the welder with you. And what I didn't do yesterday is I didn't release a quiz. So today I didn't make a quiz. And I'm going to ask you to go back to yesterday's unit and complete that quiz from yesterday. It's going to be in identifying and matching parts, pieces, and components of that machine right there. So this whole lesson revolved around that quiz. So it's got everything from the power source welder on it to ground clamps, ground cables, electrodes, electrode holders, all that. Basically, it's going to have A, B, C, D, E, F, G, H, I, J. You tell me what those things are. It's even got a work table in it, a welding table. So I've just given you half a dozen answers right there. So let's jump on that. I'm going to get that opened up real quick. If you haven't dropped your name in the chat, please do so, people. I've got 15 of you here. I want to have 15 on my chat list. So I've got 15 on my attendance list. Because it always sucks when somebody emails me saying, oh, hey, Mr. Scott, I was there, but I didn't put my name on the list and I got a phone call home, so can you please change that? I'll do it, no problem. It doesn't bother me, but it just sucks that you had to get that call at home. So getting your names in the chat is how we're going to eliminate that. So once again, thank you for coming in, folks. I really appreciate it. I hope we can get ourselves in the booth here. That quiz today is going to be nice and quick. And I would really love it if you guys could take care of a couple extra quizzes that you guys haven't yet. Because when you guys go on break, I want you to have a break. I don't want you, to be working on homework in 4 courses because we're all running to finals in these courses. We talk about math finals, science finals. We might have socials, ELA, whatever we're doing. You guys got enough stress going on that you don't want extra stress from me. So if you guys just take care of my stuff nice and quick, then you guys are golden. There is no final test for welding. That's the beautiful thing about it. I'm not doing a big final test. I do little mini tests the whole way through, and that keeps it easy. That's why I like the way this course is set up, and I like teaching it. Because I'm not like, okay, we're going to prepare all semester for a big test. That's not how I do it. It's not how it works. So thank you guys for joining. I'm going to shut off the video and the recording and the mic. I will be here for 15 minutes. So if you guys need help with something, yell at me, get my attention, whatever. I got you. So if you want to send me an email, do that too. Thank you much, folks. Have a great day, and I will talk to you tomorrow.